Hello and welcome to another video of Vivek Learns. So this is the part 3 of the series where I am trying to solve problems of PepCoding Level 1. So in the earlier videos we have solved the fib till n. Like we were given a number and we were told to print all the Fibonacci numbers till that given number. So in the current video we will continue to solve more problems of PepCoding Level 1, right? So let's start with like this one. We had done this print Fibonacci number of till n, right? And then let's start with this one. Count digits in a number. You have to count the number of digits in a number. Take as input n the number for which the digit has to be counted. Print the digits in that number. Okay, so let's see an example here. So we have this number 65784383. So we have to count the digits of this number. So the digits are 1, 2, 3, 4, 5, 6, 7, 8. So the output will be 8, right? So how will we approach this problem, right? So what we can do is that we can have the number here and we can have a counter variable, right? Right. So initially the counter will be 0, and as we iterate through this number, we will increment the counter, right? So how do we increment the counter? How do we remove one digit from the number per iteration? So what we can do is that we can divide the number by 10. So what will be the output of this? So it will be everything except this 3, right? We won't get a decimal value because both of these numbers are integers. So the output will be integer itself. Okay. And for the next iteration, what we can do, we can again divide this number by 10. And then what we get is everything except this. Like the last digit will be gone, right? So what we can do is that in this step we can increment the counter by 1. Here also we can increment the counter by 1. Sorry. And in the similar way, we can again divide by 10 and increment the counter. And till what till what do we have to do this? Till what range? We have to do it until we get 0. And how will we get 0? So the last iteration will be 6 by 10, which is equals to 0, right? And we have to then break through this loop. So let's try to code this, right? So we'll create a new class. Count digits, right? And we have to take an input. So let me copy this snippet, which will help me take input. Let me name the input number as num. Okay, so we get num, and we have to iterate till uh, the num is 0. But before that, we'll have a counter variable, which is 0. So I have chosen the while loop here because we don't know the exact number of iterations that we are going to have, but we know the condition for which we have to stop, right? So I have used a while loop here instead of a for loop, right? And what do you have to do is that we have to increment the counter here, okay, the digit counter. And we have to increment the digit counter, and what we have to do is that we can have this in any of the order. Like we can first divide the number by 12 and then increment the counter, or either way is fine. The order doesn't matter. And we have to iterate till we get the num as 0, right? And then we'll print count of digits. Yep. So let's try to run this. Okay, that's right. 1, 2, 3, 4, 5, 6, 7, 8. Yep, we have 8 digits in this number. So let's move to the next problem, right? Digits of a number. You have to display the digits of a number. Take as input n the number for which to for which digits have to be displayed. Print the digits of the number line wise. N, where n is any integer. Okay, so let's see an example. So we have this number given and we have to print the digits of that number. Okay, so let's see. So let's take this number. So suppose we have the background of the previous one, right? And we have the digits counter, right? We have the digits counter set to 6. Oh, my bad, 8, right? And now what we can do to calculate the digits of the number is that we can, hmm, what we can do? We can have a division of this number by 10 to the power 7. And then we'll get 6, right? Okay. What will happen if we divide by 10 to the power 7? 1, 2, 3, 4, 5, 6, 7. All these digits will go away, right? Because we don't have a decimal point. Basically, the answer will be something like 6 point if we try to divide it mathematically, right? The answer will be something like 6.585784,383. But if both of these are integers, the output will be integers. And then, so we have got the first digit. After that, we have to get the second digit, right? To get the second digit, what we can do is that we can have modulus of this, right? So we have this number, and then we have to bar 7, which is like this number will get deleted. And then we can have this logic. mm, we can have this logic iteratively, right? So we can, for the next iteration, we can divide the number by 10 to power 6 first to get the digit, and then we can replace the number with um, mod of this number, uh, mod of 5784383 mod 10 to power 6. That will be the new number for the next iteration. So let's try to code this. So this problem is similar to the last one. So let me have a reference implementation here. Okay. So before that, what I will like to do is that we can have this number stored in a temporary variable, right? Because we have to do the iteration two times. We have to iterate through that number two times. The first is for counting the number of digits, right? And the second is when we have to print the digits, right? So what will be the condition, like when to break this? So the breaking condition for it will be similar, right? When the number is 0. So we have to stop when the number is, like when this particular number gets to 0, right? So temp, we have to use the temp num variable here, right? Temp, um, temp num divide by, oops, sorry, so I'm mistakenly hitting the caps lock button again and again. Sorry for that. Temp num. Then what we have to do is that we have to divide it by math dot power of 10 to power something, right? Math dot power. But what we get is a double value here, right? Digit counter minus 1. Okay, so what we get here is a double value, so we have to convert that to int. Okay, sorry. What we have to do is that we have to print the digit. And then we have to introduce this temp num is equals to temp num mod, right? Mod this whole value again. Oops, sorry, I mistakenly copied the division sign also, right? And we have to decrement the digit counter as well, right? So first we get the digits of the number, and after that what we do is that we divide the number by 10 to power digit minus 1, so we'll get the first digit, and then we replace the digit with, like, the number with the number mod 10, so the first digit will be gone, right? And we just get 5784383, and we continue the iteration. So for the next iteration we have to take this number and we have to first divide with 10 to power 6, right? Which is nothing but this number, right? Because 1 2 3 4 5 6, all these numbers will come after the decimal point, right? Oops, my bad. 10 to power 7 will get 5, right? And all these numbers that I had highlighted will come after the decimal, so we won't get those values here. So to get those values, what we have to do is that we have to take a modulus, right? Not a division. 10 to power 6, which is this number, right? So what we do is that we replace the number with this number, with the model, by taking the modulus. Like the new number is the previous number mod 10 to power digit counter minus 1, which is the new number, right? So let's try to run this for this. So we do get the output as 657 84383, right? 84383. Yep. So let's move to the next question. Okay. So the next question is reverse a number. So let's read the problem statement first. You have to display the digits of a number in reverse. Take as input n the number for which digits have to be displayed in reverse. Print the digits of the number line wise but in reverse order. Okay. So we have this number. We have to print the digits of that number in reverse order, right? So how will we approach this problem? So in the previous problem, what we had done is that we had printed the digits of this number, but from left to right, right? But now what we have to do is that we have to print the digits of the numbers in the reverse order. So what we can do is that we can you know go through the counter example that we had seen, and what we had done there is we had divided the number by 10, and uh, what happened there was the last digit, okay, was lost. And what we can do, we can regain that last digit by taking a modulus 10. So what we'll get is 3, right? Because all these numbers will come before the decimal. And what modulus does is, whatever comes after the decimal, it gives us those values, right? So, my bad, it will give us 3, right? Sorry. So what we can do is that we can have this number first, okay? And we can take a modulus of this number to get the last digit. And then the new number can be the previous number, which is this, divided by 10. So we'll lose the last number. And then we can again follow this same steps, right? We can have this number, take the modulus of it, which will give us the last number, which is 8. And after that, we get the new number by taking the division of the previous number, right? And the cycle continues. Okay, so let me create a new class. So let's do something different in this question, right? What we can do in this question is we can, instead of printing these numbers in a line, let's have the numbers in the reverse order. So let's see, we have this number, okay, right? And the new number that we expect as output will be 383485756. Okay, let's modify this question a bit and let's try to find out, let's try to do this, right? So this is similar to the count the digits of a number problem, right? So let me copy this snippet from the previous problem which we had solved in this video. So first let's print the digits, right, in the reverse, and then we'll do the second part of the problem. Like we will have a new number generated which is the reverse of the current number. Okay, so we have this digits counter number, which is a digits counter variable which is not needed now. And what we need to do is we need to take a digit variable which is nothing but the modulus of num mod 10, and we have to print it. So let's try to print the number first, and then we'll go to the second part, right? Okay, let me run this problem. Okay, so it will print 3, 8, 3, 4. That's our expectation. Yep. So it will print 3, 8, 3, 4, 8, 7, 5, 6. Right. And now what we have to do is that we have to generate a new number. Let's say that number is reversed num. Let's assign that a value 0. What we have to do is that the reversed num will collect all these digits that we have, right? So how will we do that? So we'll get the digits first in the reverse order, and then what we can do is that we can multiply that number by we can multiply the digit by 10 and just add it, right? Okay, so let's say we have the first number. Let's consider number 2, not 1. Okay, so first we'll get 1. What we'll do is that we'll um, have 1 plus reversed number, right? And then what we can do is that we can have 1 plus reverse, like the reverse number will be equal to 1 plus reverse number. And for the next iteration, what we can have is reverse number plus we can have 0 times 10, right? And then what we can have for the third iteration will be plus 2. Oops, sorry, my bad. Mm, what we can do here is we can have the reverse number times 10 plus the digit. Okay, and we'll have this given to the reverse number, right? So for the first one, what we'll get is we'll get reverse number was 0 plus uh, 0 times 10 is 0 plus the digit is 1. So for the first iteration, it will be 0 plus 1, which is 1. For the second iteration, we'll have reverse number is 1 times 10 plus the digit, which is 0, which is nothing but 10. For the third iteration, what we'll have is reverse number, which is 10 times 10 plus the digit. What is the digit for the third iteration? 2, which will give us 1 not 2. So this is the expected output that we want, right? So let's try to have this logic implemented here. So we get the digit and we don't print the digit now. We directly have reverse num is equals to reverse num times 10 plus digit, and then we print the output. So let's try to do this. Okay. Oh, my bad. We have to do times 10. My bad. Let me run this again. Yes. what we get is the reversed number. Let's try it for another number, like the one that we solved. Two, like we had solved it for 201, but let's solve it for 2001. Right? We should get 1002. Yep. So yeah guys, that's all for this video. See you guys in the next one.